Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a topic from the SAT and ACT math sections that looks pretty complicated when you see it at first and appears on what the tests call hard questions, but when you know what's going on with this equation, it's really not that bad. That equation is the circle in a coordinate plane formula. So let's take a look. Okay, quick note before we dive in here. This video is a follow-on to my video on sectors of a circle. There are really three levels to circles in the math sections of these tests. The first being the basics, the second is sectors, and the third one is this, circle in a coordinate plane. So if you're shaky on area, circumference, or sectors, I would go watch this video first before you dive in here. But if you are confident with those basics, let's take a look at this equation. So the equation is x minus h squared plus y minus k squared equals r squared. And that is what you will see 99.9% of the time. There is another form of a circle in a coordinate plane equation, and that's x minus h squared over r squared plus y minus k squared over r squared equals 1. That's the same thing, just everything's been divided by r squared, but you're going to see the first one. And, that is quite a lot of letters there in one equation. But if you see my other video on distance and midpoint formula, you'll know that there's a lot of letters in those equations as well. But they're pretty straightforward if you just think about the concept. And if you think about the concept of what's going on here, the same thing is true. So let's take a look. So if we're thinking about a circle in a coordinate plane, so circle on a grid, basically, there's really only two things that you can know. Those two things are where is the circle, and the way we're going to think about that is where is the center of that circle, and how big is that circle? Because unlike a straight line or a parabola, if you rotate a circle around, it's not going to make any difference because it's a circle. And so the nice thing is this equation organizes those two concepts, size and location, really neatly. And in that equation here, the left side is just the location, and the right side is the size. And the way that the location works is really similar to the way that the x-coordinate in the vertex form of a parabola works, which is just the way that anything inside of parentheses work for function shifts. So if I had something like x minus 4 squared plus y plus 6 squared equals 25, all that would mean is, so left side location, what we do is we take whatever the sign of the constant is inside of the parenthetical and reverse it. So the center there is just the opposite of -4 is +4 for the x-coordinate, and the opposite of +6 is -6 for the y-coordinate. So 4, -6 is the center of the circle, and the radius is even easier. It's just the square root of 25, which is 5. So that's just a circle centered on the point 4, -6 with a radius of 5, which is really easy to visualize. Okay, let's clear that out and look at one more point about this. So it's important to know that the circle must conform to the general equation. So if you saw something like 2x squared plus 5x plus y squared plus 4y equals 15, you would need to adjust that to make it look like the form x minus h squared plus y minus k squared equals r squared. The SAT and ACT will never give you something as ugly as what I've written here. This would just be a total bear to turn into the correct form, but it will be something that you may need to complete the square for. So just a little hint there for something we may do later. But generally, those are the topics to think about for circle and a coordinate plane. Let's go ahead and do some practice problems and see if it doesn't make sense. Okay, 2 practice problems here. Take a second and see if you can't solve these. Okay, let's take a look, and we'll investigate the first one. Let's get a little closer. Okay, in the xy coordinate plane above, the circle has center hk, and the radius is 15. What is the value of k? K there being the y coordinate of the center of the circle. So just good practice, we're going to draw a triangle in here just to help us understand where our axes will be, where we might get a little clue as to what length is what. And they tell us that the radius is 15, so we can go ahead and draw that in here. And we know that this is a right angle because we're in the coordinate plane. And we have these 2 points here, and these being along the circle, so we know that we have a radius between these points in the center. We know that distance is 24 because we have the point 2, 0 and the point 26, 0. So that's 24. And since these angles are the same, we know that this is an isosceles triangle. We also know it's an isosceles triangle because both of these are 15 because they're both radii. And that means that this is halfway between, so we can divide this by 2 and get 12 right here. And you may pick up here that we don't need to do Pythagoras because this is a 3, 4, 5 triangle, because 15 is 3 times 5, 12 is 3 times 4, and then the other side would be 3 times 3, which would be 9. Okay, let's clear that out and look at the next one. And I'd say the next one is a little bit or even a lot bit more challenging than the first one. So as I mentioned earlier, sometimes they'll give you the equation for a circle not in the form that is required. And if you've done vertex in that whole series, you'll know how to complete the square, which is ironically what we need to do here for making a circle hole is apply completing a square to it. So instead of having x squared plus y squared plus 8y plus 5x equals negative 25 quarters, I'm going to organize this in such a way that all the x's will be together. X squared plus 5x plus, well, we're going to have to add something to that because we're going to need to complete that square. And then we're going to have plus y squared plus 8y plus something else equals negative 25 over 4. And to complete the square, we're going to take whatever that b value is right there, which is 5, divided by 2 and square it. And, people will say, well, half of 5 is 2.5, and then they'll attempt to square that, and they'll get a calculator out, but I'm lazy, so I'm going to say that half of 5 is just 5 over 2. And so then 5 over 2 squared, that's 25 over 4. And the nice thing there is you'll notice that that's a similar fraction to what we're doing on the right side there, which is part of that quarter is there. So if we're going to add 25 over 4 to this side, we need to add 25 over 4 to the other side so our algebra works correctly. And then 2, it's kind of convenient that that cancels out. And then for completing the square for the y, we're going to say half of 8 is 4, and 4 squared is 16. So we're going to add 16 to that side. And we can go ahead and say that these two cancel out. We're going to have 16 on the right. And if we wanted to know the radius for that, we could just square root that right away and get 4. I'm going to also just complete the other side as well for the sake of being thorough. So x squared plus 5x plus 25 over 4 is going to simplify to x plus 5 over 2 squared. And y squared plus 8y plus 16 can be simplified to y plus 4 squared. So if you were wondering, the center of this circle is negative 5 over 2, comma, negative 4. And the radius is 4. Okay, that's it for this video. Hopefully I've been able to illustrate that the equation for a circle in a coordinate plane may have a lot of letters, but really isn't that complicated. And when in doubt, just remember, location on the left and size on the right. And if the example problem that I did where I completed the square was a little shaky or unfamiliar, look for a video from us coming out soon where we cover that topic. If you found this material useful, we hope that you will like, share, and subscribe to Quad Education. Thank you for watching, and I hope you have a great day.